Hello, my name is Mark Anthony Taylor. This is part 2 of the David Icke critiques. That is studying David Icke's worldview in the hope of allowing him, or anyone else, to refine and extend his ideas. In this video, I'd like to discuss problems of general relativity. General relativity is the theory of space-time curvature as a result of the presence of matter. This is a theory that replaced Newtonian mechanics. In Newtonian mechanics, gravity is a force between bodies that brought them together. In Einstein's general theory, objects follow the curves of a curved space, so that gravity is responsible for curving space, and then objects react to that curvature. Now, in my first lecture, I discussed the quantum measurement problem, and I showed that every quantum solution, every scenario in quantum mechanics is missing the observer, his apparatus, and the means to determine the structure of space and time in the universe through which the wave function or the field or the vibration or what you will exists. Now, in general relativity, I believe there's a similar problem that is under-acknowledged in the scientific community, but it's a big community, so I won't pretend to have unique knowledge unless I knew that for sure, and I don't know that for sure. Now consider an empty universe with no matter. According to general relativity, that should be a flat universe where the geometry follows the rules of Euclid and Pythagoras, a flat space-time. But in such a universe, there's no clocks or rulers. In other words, there's no way to give physical meaning to space and time. If you were to introduce such clocks and rulers made out of ordinary matter, and when we speak of the geometry of space and time, we really mean the geometry of ordinary matter. So when we introduce clocks and rulers, we introduce matter into the empty universe that causes curvature. So now we no longer are measuring the geometry of the empty universe, but one full of measuring apparatus. So as you can see, this is a measurement problem. More generally, if you have some kind of curved space-time and you try to validate the length across a curve, the moment you introduce clocks and rulers along that curve, you change the curvature because you've introduced more matter into the region, which creates a gravitational force. And there's any number of ways of arranging clocks and rulers in order to measure distances and time periods. So there's no simple solution. Also missing from that universe is the observer, whose job it is to count rulers and count the ticking of the clock. So in general relativity, we have exactly the same measurement problem as we found in quantum mechanics.